Imagine this. Millions of colorful balloons float through birthday parties, weddings, sporting events, and celebrations every single day. They look so simple that most people never stop to ask where they actually come from, or how something thin enough to see light through can stretch to several times its original size without bursting. But here's what nobody tells you. Every latex balloon begins its life as a living tree deep inside a tropical rainforest, and before it reaches your hands, it travels through one of the most fascinating manufacturing journeys on Earth.
Today, we're taking you inside a world few people ever get to see. You'll follow liquid latex from the moment it drips out of a rubber tree to the instant thousands of perfectly shaped balloons roll off automated factory lines every single hour. Along the way, you'll discover chemistry, precision engineering, hidden quality tests, and surprising facts that even experienced factory workers still find incredible. And the closer we get to production line, the stranger this story becomes. Today, we're taking you inside a world few people ever get to see. You'll follow liquid latex from the moment it drips out of a rubber tree to the instant thousands of perfectly shaped balloons roll off automated factory lines every single hour. Along the way, you'll discover chemistry, precision engineering, hidden quality tests, and surprising facts that even experienced factory workers still find incredible. And the closer we get to production line, the stranger this story becomes. Everything begins with the rubber tree, Hevea brasiliensis. Although the species originally came from the Amazon rainforest in South America, today more than 90% of the world's natural rubber comes from Southeast Asia. Thailand produces roughly 35% of global natural rubber, followed by Indonesia, Vietnam, Malaysia, and India. Warm temperatures between 25 and 35 degrees Celsius, abundant rainfall, and rich tropical soils create the perfect environment for these remarkable trees. A rubber tree doesn't produce latex overnight. Farmers usually wait 6 to 7 years before making the very first cut into its bark. Using an extremely sharp curved tapping knife, they shave away only a paper-thin layer, careful not to damage the living tissue beneath. As soon as the bark opens, milky white latex begins flowing into a small collection cup. The forest grows quiet except for the soft, steady drip, drip, drip of liquid rubber filling hundreds of cups before sunrise. Fresh natural latex contains roughly 35% rubber particles suspended in water. The remaining 65% includes proteins, natural sugars, minerals, fatty acids, and trace compounds that help keep the latex stable inside the tree. Left alone, this liquid begins coagulating within hours. To prevent that from happening, workers immediately add a carefully measured amount of ammonia, typically around 0.7% by weight, which keeps the latex fluid during transportation. Every collection bucket travels to regional processing centers, sometimes covering more than 100 kilometers by truck before the tropical heat can spoil the latex. Large centrifuge machines spin the liquid at nearly 6,000 revolutions per minute, separating excess water and increasing the rubber concentration from about 35% to nearly 60%. The thicker concentrate flows like heavy cream, smooth, glossy, and ready for manufacturing. Color deserves its own science. Manufacturers use highly purified mineral and organic pigments designed to survive sunlight, stretching, and repeated handling without fading. Every batch undergoes spectrophotometer testing to ensure the color matches within incredibly tight tolerances. Whether it's bright red, deep blue, emerald green, or metallic gold, consistency matters because customers expect every balloon in a package to look exactly the same. Most people never think about the supply chain hiding behind a single-party balloon. Natural latex may travel more than 10,000 kilometers from plantations in Thailand or Malaysia to factories in Europe, North America, or South America. Every shipment stays inside carefully sealed containers to protect it from contamination and extreme temperatures. A delay of only a few days in the wrong conditions can ruin an entire shipment worth hundreds of thousands of dollars. The moment the latex enters a production floor, everything changes. You're standing inside a warm factory where conveyor chains stretch farther than the eye can see, carrying thousands of spotless ceramic balloon molds through a carefully choreographed journey. The air smells faintly of fresh rubber and warm ammonia, while motors hum with perfect rhythm. And this is where a tank of milky liquid begins transforming into something millions of people will celebrate with. Before a single mold touches latex, Every ceramic former must be perfectly clean. High-pressure water jet spray at nearly 5 bar or 73 psi, washing away microscopic dust and leftover rubber from previous cycles. The molds then pass through rotating brushes before entering drying ovens heated to around 70 degrees Celsius or 158 degrees Fahrenheit for nearly 8 minutes. Even a fingerprint could leave a weak spot in the finished balloon. So absolute cleanliness isn't optional. It's essential. Next comes a step almost nobody outside the industry knows about. The warm ceramic molds enter a coagulant bath containing calcium nitrate, water, and a tiny amount of release agent. The bath stays close to 55 degrees Celsius or 131 degrees Fahrenheit, and each mold remains submerged for roughly 5 seconds. As the molds emerge, they carry an invisible coating that will trigger the latex to solidify in exactly the right shape. Now comes the magical moment. Thousands of molds slowly descend into the latex tank at a carefully controlled speed of about 0.2 meters per second. The liquid hugs every curve as microscopic rubber particles instantly begin collecting on the treated ceramic surface. The dip lasts only 8 to 12 seconds, yet during those few moments a future balloon quietly takes shape, one invisible layer at a time. At first glance, every balloon looks perfect, but appearances can be deceiving. Hidden pinholes smaller than a grain of dust, microscopic variations in thickness, or tiny chemical defects could cause a balloon to burst long before the party even begins. So before a single package leaves the factory, every batch faces a series of surprisingly brutal tests that push the rubber far beyond anything you'll ever see at a celebration. And that's where our journey heads next. The factory may smell like warm rubber, but behind the scenes it thinks like a supercomputer. Every minute, thousands of sensors watch temperatures, conveyor speeds, latex viscosity, humidity, and chemical concentration without taking a single break. One small change, just a few degrees or a slight shift in viscosity, can affect tens of thousands of balloons before anyone notices. That's why modern balloon factories trust data as much as they trust chemistry. Laser measurement systems add another layer of precision. They measure balloon dimensions with tolerances as small as plus or minus 0.2 millimeters, ensuring every balloon matches the manufacturer's specifications. Even tiny differences in wall thickness can change how much air a balloon holds or how easily it bursts. Most people never think about this, but consistency is what makes thousands of balloons behave exactly the same. When a defect appears, automation reacts instantly. Pneumatic arms powered by compressed air at roughly 6 bar or 87 psi remove rejected balloons without slowing production. Some factories inspect more than 35,000 balloons every hour, yet maintain rejection rates below 1% thanks to continuous monitoring and automatic process adjustments. Machines never get tired, and they never lose concentration. But passing a visual inspection isn't enough. Random balloons travel to a testing laboratory where technicians inflate them until they finally burst. Standard balloons often expand to more than 700% of their original volume before failing. The room suddenly fills with sharp popping sounds that echo off the walls, while engineers quietly record every measurement. Each explosion tells a story about the quality of the rubber. Another test checks air retention. Balloons stay inflated for hours or sometimes days, inside climate-controlled chambers held at around 23 degrees Celsius or 73 degrees Fahrenheit, with carefully regulated humidity. Engineers monitor pressure loss over time to verify that the rubber forms a nearly airtight barrier. A balloon that leaks too quickly never reaches store shelves. By now, every balloon has survived chemistry, heat, automation, lasers, cameras, pressure tests, and the trained touch of human experts. It seems like the journey should be over, but here's the surprise. The real story of latex balloons isn't hidden inside the factory at all. It's hidden in the astonishing numbers behind an industry that quietly supplies billions of balloons to the world every year. And those numbers are far more unbelievable than most people could ever imagine. Now step back and look at the bigger picture. The global balloon industry produces well over 100 billion balloons every year, with latex balloons making up the largest share of that total. If you line those balloons up end to end, they would wrap around the Earth thousands of times. What seems like a tiny party decoration is actually one of the world's most widespread manufactured products. And demand continues to grow with every celebration, festival, and sporting event. The worldwide balloon market is now worth more than $3 billion US, serving customers in nearly every country on Earth. The largest demand comes from birthdays, weddings, advertising, festivals, schools, and corporate events. Seasonal holidays create massive spikes in production, forcing some factories to operate around the clock. During peak seasons, every hour matters. Today, Thailand remains the world's largest producer of natural rubber, with roughly 35% of global output. Indonesia follows with about 24%. Vietnam contributes around 8%. India produces approximately 7%, and China counts for close to 6%. These 5 nations supply the raw material that keeps balloon factories operating across the globe. Without them, production would slow almost overnight. Did you know that one mature rubber tree can produce latex for more than 25 years? Did you know a single automated production line can manufacture tens of thousands of balloons every hour? And here's the most surprising fact of all. The rubber inside many latex balloons comes from a renewable resource that naturally regrows every time the tree produces fresh latex. What looked like